Have you ever thought about what it would take to measure the universe?
Hmm.
Like way back before we had, well, any of the tools we have today.
Yeah. Kind of hard to imagine, right? Trying to grasp those cosmic distances with just your mind and the naked eye.
Yeah, like imagine someone in, say, India in the 5th century trying to figure out the size of the Earth or the distance of the sun. Just boggles the mind.
It really does. But that's exactly the challenge that someone like Aryabhata took on. He was this incredible astronomer and mathematician.
Right, Aryabhata. We're diving back into his work today on the deep dive, picking up where we left off. Last time we were exploring those mind-blowing concepts of cosmic time cycles, remember? Like the Kalpa.
Oh, yeah, the Kalpa, like a day for Brahma, the creator god, a
Yeah.
billion years for us mortals.
Exactly. A timescale so vast it makes your head spin.
Hmm.
And that sets the scene for what we're getting into today, right? Because now we're moving from those stretches of time to thinking about the actual distances involved, the size of things in the cosmos.
We're going to be zeroing in on verses 6 and 7 from Aryabhata's famous work, the Āryabhaṭīya.
The Aryabhaṭīya, right?
Yeah.
And those verses, they basically lay out his measurements for the whole universe, well, as he understood it. The celestial sphere, the earth, the sun, the moon. It's a pretty amazing glimpse into how people tried to make sense of their place in the cosmos back then.
And what's striking is that Aryabhata wasn't content with just like philosophical ideas. He
Yeah.
wanted to make it all very concrete.
You mean like a quantifiable model?
Yeah, exactly. Like he was building a kind of machine, of size and motion, all expressed through numbers.
Okay, so let's set the stage. Picture it. India, 499 AD. We're in the Gupta Empire, a real golden age, right?
A time of flourishing arts and sciences. And we're in Kusumapura, this bustling city known for its vibrant intellectual scene.
A real hub for scholars from all over. I bet it was buzzing with ideas. You can almost smell that fragrant jasmine in the air, right?
Absolutely. And imagine like the sounds of the city, the markets and the music and all that. But then in these quiet courtyards, you have these scholars hunched over their manuscripts working by lamplight.
I love that image. And that's where Aryabhata was, right in the thick of it, pushing the boundaries of knowledge.
Totally. And just like we talked about those huge cosmic time cycles from verse 5, the Kalpa, he goes on in these next verses to lay out a universe that's equally vast in its spatial dimensions.
And he starts by introducing this idea of the Kaksha. Now, for those of us who aren't ancient astronomers, what exactly are we talking about here?
So the Kaksha is basically Aryabhata's conception of the celestial sphere. Imagine, this huge dome encompassing everything you see in the night sky, like the ultimate cosmic container holding all the stars.
Okay, so kind of like a giant shell surrounding everything.
Exactly. And in Aryabhata's model, this celestial sphere rotated around a stationary Earth carrying all the stars with it. That's how he explained their daily movements.
Interesting. So he wasn't thinking of the Earth moving like we do today. The whole universe was spinning around us.
Yep, that was the prevailing view at the time. And what's really fascinating is that Aryabhata didn't just describe this sphere in vague terms. He actually tried to measure it.
Wow, that's pretty ambitious. So how did he go about doing that? I mean, without any telescopes or satellites?
Well, he used a combination of observation, geometry, and this ancient unit of measurement called the yojana.
Oh, yojana. And just to give our listeners a sense of scale, what's a yojana roughly equal to in, say, miles?
It's a bit tricky because the exact value is still debated, but most scholars agree it was somewhere between 5 and 9 miles. So imagine trying to measure the universe with, a measuring stick that long.
Yeah, that puts things in perspective. I mean, it blows my mind that he even attempted it. Okay, so let's dive into the actual measurement. This is where verse 6 comes in, right?
Right. So verse 6 of the Aryabhaṭīya says, Kaumanam yojana ungulakakya mondochanam potufaganchadavanta.
Whoa, that's a mouthful. Can you break that down for us? What part of that is actually giving us the measurement?
Well, the key phrase for the size of the Kaksha, the celestial sphere, is ingala yojane. That's where he lays out his numerical value.
Ingela. And how did he represent numbers? Like, did he have a symbol for each digit?
He used this really interesting system where syllables corresponded to specific numbers. It's kind of hard to wrap your head around at first. But in this case, Onge represents the number 5, Yi represents 3,000, and La represents 50.
Okay, so you add those together, 5 plus 3,000 plus 50, and that gives us 3 of 55 yojanas for the diameter of the celestial sphere.
That's what it seems like at first glance, yeah. But there's a bit of a wrinkle.
Uh-oh, what's the catch?
Well, if we use that 5 to 9 mile range for a yojana and multiply it by 3055, we get a diameter for the celestial sphere that's smaller than the circumference of the Earth. And that doesn't quite make sense, does it?
Hmm, not really. I mean, if the celestial sphere holds all the stars and it's supposed to be rotating around the Earth, it would have to be way bigger than Earth itself.
Exactly. And that's where the interpretation of this verse gets really interesting. Some prominent scholars, like Bhaskara I and later K.S. Shukla, have argued that Ingalo was actually meant to represent a much, much larger number. Like based on Aryabhata's numerical system and the context of the verse, they suggest it was intended to convey 3,300,750,000 yojanas. That's 3.3 billion yojanas.
Wow, that's a huge difference. So what does that give us in terms of, like, miles?
Well, if we take that 3.3 billion and multiply it by our 5 to 9 mile range for a yojana, we end up with a celestial sphere that's somewhere between 16 and 30 billion miles in diameter.
That's a mind-boggling distance. I mean, that's truly astronomical. But it makes a lot more sense, right, given what we know about the vastness of space.
Right. And if you think about it, in Aryabhata's model, with the Earth at the center and this huge sphere spinning around it every 24 hours, that sphere would have to be incredibly vast for those stars to be traveling at believable speeds.
Right, because if it was too small, those stars would have to be zipping around at ridiculous speeds to complete a full rotation in a single day.
Exactly. And there's another interesting detail in that verse, too, that term kahomanam.
Tahomana.
Yeah. And that word seems to be connected to the idea of a day's measure or something related to daily observation. So it might be further emphasizing how the size of the cosmos is related to its daily rotation as seen from Earth.
I see. So not just a random number, but something tied to our earthly perspective.
Right. And what's really cool is that verse 6 also tells us that the same massive measurement applies to the apogees, the farthest points of celestial bodies, and the nodes, those crossing points in their orbits.
The ones we talked about in verse 4, right?
Yeah, exactly. So it's like he's suggesting this underlying unity in his cosmic model. You know, the same distance that defines the outer boundary of the universe also governs the movements of these celestial bodies within it.
So he's not just throwing out random numbers. There's a system, a logic to his model.
Absolutely. A real attempt to create a coherent picture of the universe, even if it's different from our modern understanding.
Okay, so we've got this picture now of this colossal celestial sphere, but verse 7 zooms in a bit closer, right? It gets down to the nitty-gritty of measuring the Earth, the sun, and the moon.
Right. Verse 7 is where he gets more specific. It starts like this. Nuruyojanam nila buvaso arkashashanki organio. Punasar gunita shiel bruguguru bodushani bonam.
Another tongue twister.
Yeah.
But before we get into the actual measurements, let's go back to the yojana for a second. You mentioned this word nui in connection with it here. Does that give us a more concrete definition of its size?
It does. Nurya, in this context, basically means 8,000 human heights. So that's a more tangible way to visualize it, even though it's still going to vary a bit depending on how tall you think the average person was back then. But it reinforces that 5 to 9 mile range we were talking about.
Okay, that helps. So with that in mind, what does Aryabhata tell us about the size of Earth?
He uses the term buvaso, which refers to the Earth's diameter, and he gives us a value of nila, which corresponds to 1050 yojanas.
And 1050 yojanas for the diameter of Earth. So if we do the math, using that 5 to 9 mile range for a yojana, what does that work out to in miles?
We get a range of about 5,250 to 900, 450 miles for the diameter of the Earth.
Hold on a sec, that's pretty close to the actual figure, isn't it?
It is. The modern measurement for Earth's diameter is about 700 and 918 miles. So considering he was working over 1,500 years ago, that's incredibly accurate.
It really is. I mean,
Wow.
how did he manage to figure that out so precisely without any of the tools we have today?
It's thought that he might have used some sophisticated shadow-based techniques. You know, like imagine measuring the angles of shadows cast by objects at different latitudes. By applying geometric principles and making very careful observations, you could calculate the Earth's circumference and then from there its diameter.
Wow, that's pretty ingenious. Okay, so he nailed the size of Earth. What about the sun and the moon? What did he say about their sizes?
For the sun, he gives us a measurement of Arkashashangyor, which corresponds to 14,410 yojanas. And for the moon, it's Ganinu, which translates to 315 yojanas.
All right, so let's crunch those numbers. What kind of diameters are we talking about in miles for the sun and the moon?
Well, for the sun, that works out to roughly 22,000 to 40,000 miles in diameter. And for the moon, it's about 1,575 to 2,035 miles.
Okay. So the sun's estimated size is significantly smaller than what we know today. But the moon's diameter, that's surprisingly close to the actual figure of about 2,159 miles.
And what's also really interesting is that based on his measurements, the moon is roughly 30% the size of the Earth. And that's pretty much spot on with the actual ratio.
It's amazing how much he was able to figure out, even with the limited technology of his time.
Hmm.
And these measurements, they weren't just about satisfying curiosity, they had practical implications too, right?
Absolutely. Knowing the sizes of the sun and moon and their relative distances from Earth was crucial for understanding how eclipses worked.
Makes sense. Like how the moon could perfectly block out the sun during a solar eclipse, or how Earth's shadow could cover the moon during a lunar eclipse.
Exactly. Aryabhata's calculations provided a more scientific framework for understanding these phenomena.
And he even went on to mention other planets in that verse, didn't he?
Yeah,
Like Venus, Jupiter, Mercury, Saturn,
it
Mars.
did. It was just a quick mention giving relative measurements based on the size of the Earth, but it shows how he was trying to create a comprehensive model of the entire cosmos.
It's incredible. So when we step back and look at the big picture here, what do you think is the most significant takeaway from Aryabhata's measurements in verses 6 and 7? Like, what did it mean for people back then, and what does it tell us today?
Well, I think it was a profound shift in how people thought about the universe.
Right.
Aryabhata was basically saying, hey, this cosmos isn't just some mysterious, unknowable realm. It's something we can measure, something we can understand through math and observation. He gave a structure, a framework to the universe.
Yeah, it must have been mind-blowing for people back then to think about the heavens, their own planet, the sun, the moon, all expressed in numbers. It took cosmology from the realm of myth and speculation and grounded it in something more concrete, more quantifiable.
And, for a culture that was already so advanced in mathematics and astronomy, Aryabhata's work was like the next logical step. It's like he was building this intricate cosmic machine where everything had its place and its size, all laid out in this elegant mathematical language.
It's amazing to think how human curiosity and ingenuity have always driven us to understand the universe, even without the technology we have today.
Absolutely. And the fact that we can use AI today to decode these ancient texts and see how close he got with his calculations, it's a testament to that enduring spirit of exploration and discovery.
So just to wrap things up for our listeners, we've been exploring how Aryabhata, all the way back in the 5th century, tried to measure the seemingly immeasurable. In verse 6, we saw how he envisioned this massive celestial sphere spanning billions of miles. And in verse 7, he gave us surprisingly accurate measurements for the Earth, the Sun, and the Moon.
And it's important to remember, even though his model was geocentric with the Earth at the center, it was a groundbreaking achievement for its time.
For sure. And next time on the Deep Dive, we're going to go even further. We'll explore how Aryabhata explained the actual movements of the stars and planets, and how his ideas influenced our understanding of the cosmos for centuries to come.
So make sure you join us for that. And don't forget to subscribe to the Deep Dive so you don't miss out on any of our future explorations.
As you go about your day, think about how this quest to understand the universe, to measure and make sense of it all, is something that connects us across time and cultures. It's a reminder that even with limited tools, the human mind can achieve extraordinary things.